In the last few videos, we have seen derivations of kinematic equations of motion. The three equations are V is equal to U plus AT, S is equal to UT plus half AT square, and V square is equal to U square plus 2AS. Now here U is my initial velocity, V is the final velocity, A is the acceleration, S is the displacement, and T is the time interval. Okay. Now these are kinematic equations of motion for constant acceleration. Okay. Now when we consider motion under gravity, now first of all let us understand what is motion under gravity. Okay. There is some object, okay, which I drop from certain height. Okay. And now note one thing, I am just dropping it. Okay. I am not throwing it. I am dropping it from certain height. So what do you understand by dropping? I am dropping, that means I was holding it, right? I was holding it and now I stop holding it, correct? So it falls under gravity. The acceleration acting on the object which is falling down, it is gravitational acceleration, correct? And then gravitational acceleration nothing but G. So A is equal to G in this case. So for motion under gravity, okay, for motion under gravity, my acceleration is equal to G, and if I drop it, my U will be equal to 0. My initial velocity is equal to 0. It's a freely falling body, correct? So then these equations 1, 2 and 3 we can write as V is equal to U plus AT. Now my U is 0 and A is equal to G, so it would be equal to G into T. My S is going to be equal to UT plus half AT square. Again my U is equal to 0, so this part is going to become 0 and remaining would become how much? It would be half GT square. And the third one, V square is equal to U square plus 2AS. Now obviously here my V square, final velocity with which it might hit the ground, would be equal to U square, that is 0 plus 2AS, so 2 into G. Now if it is falling from a height of, let us say it falls from here, so U is equal to 0, this mass is M, let us say, falling from point A here and will reach the ground at point B, and then height above the ground, if you call that height as H, then what is the displacement of that body? Is it not H? So instead of S, I will write H. So even here I can write H, the distance covered or the height covered, in that much time. So these are my three equations for motion under gravity. Now you will see that I have left some space over here. Why did I do that? Maybe I might want to insert some signs there. Yes, I want to do that. Now here that object is, it is falling vertically downwards. So general sign conventions are whatever is going up, okay, upward is positive, downward is negative, to my left it is negative, and to my right it is positive. Okay. Now here if you see, that object is falling vertically downwards, so G is acting downwards, so I might have, I might introduce a minus sign here, correct? Even here my sign would be minus and my sign would be minus here, because my G is downwards. But then at the same time there is one thing to note, that this velocity, okay, is it not downwards? My direction of V, is it not downwards? So obviously I'll make this sign also negative. My H with respect to my initial position, my H is downwards, in the downward direction, displacement is downward. So I will put this sign, negative sign here. And what about this? Again I'll now here there is one thing, if I if I put a negative sign to V, it is going to become positive, correct? And then my square of v is going to be negative in this case. So what would you do here? Will there be some problem? It looks like there will be some problem, but there won't be, because see, my g is negative, but my h is also negative. So what happens to this negative sign? So negative multiplied by negative, this will definitely become positive, and then it works out fine. Correct? So here you are putting negative sign here and negative sign for this g here. They are getting cancelled. So h in magnitude, if you see, it is going to be in magnitude, it is going to be positive. Correct? Now here it is very much necessary. Okay, in the second equation it is very necessary. Why? Because if you put g as negative and h as positive, then what happens? Then your t square would be negative, and then square of a number cannot be negative. Correct? So here putting this negative sign here and negative sign to h, that makes sense. So that was about motion under gravity. From the next video onwards, we'll be doing a few interesting problems. The problems will be on kinematics or kinematical equations of motions, and the motion under constant acceleration, and then motion under gravity. Thank you so much.